Okay, we're going to try and find the two legs from the length of the two legs from the square corner, so that we can then get this bevel and that bevel, but I don't know where that applies in anything that we're trying to do, but maybe it does. The surprises in this geometry are there to be had. So, but this is the one we want. We know that length. We know that length for a 1 meter, 1 meter run of standard rafter, both roofs being exactly the same. That length at 600 to 1000 is that distance there, 1536. We need that length. Here's what I would do. I'd come around the back here. I'll get rid of the see if I can. I'll hide that. Okay. So I may even hide that. Can I? Okay. I'm gonna need. Okay. So I need to mark this line along here on the top of the ridge. So I'll double click on that and do it all in there. Yep, that's got that. I can hide that. And I need to mark the line down here. Well, I don't know if I need to. This is just my way. Wait there. I didn't put that. I didn't put that in it. Did I put that in it? Yes. Alpha line. Click release. Click release. So that's the slope of the that triangle there is exactly the same as the this triangle here, 1 meter, 600, and the rafter. That's except it's up the other way. So then I'll hide that, and that triangle is exactly the same as that. So they're equal to. They're not even similar, we would say. And then what I want to do is I want a triangle up here. I'll take that one and I'll go Q control. And so what I'll do is I will put that there. So that's a similar triangle. That's the same triangle as that. And that three triangles exactly the same. And if I was to continue this line up here, you would say that that has to be both right angle triangles, both right angle triangles. The big triangle there is a similar triangle. So the length of the hypotenuse there of the original one would be would would influence the length of this, given that this is proportional. So that was 600 there. Now it's a meter. 1 meter divided by the 600 is 1.667. So this hypotenuse here is 1.667 times the length of that. Very easy to get the length of that. Is that significant for us? I think it is. Did I? There it is there. I don't know if I did I kill that other. So that's the length of that angle there. And this one here is that, and this one here. Oh, why is that not playing fair? Okay. I get a bit flustered when I turn the record button on. I don't know why. Anyway, that's the triangle that we need. And now we can calculate that easily. As I said, it's just a proportion or similar triangles. Similar triangles are simply what we do with steel squares. So if you're on top of that, that's easy. I think it's easy. And the steel square would be sitting in there, just ready to take that information. And it wouldn't matter then what you want to do with this. You might go, oh, well, I'll just pick a number, pick a big number there. Might just go, I'll go something consistent. So I'll go 300 there. And here is 230. This has got nothing to do with the 233 before, has it? Because that's 230 there, 232, 230, 236, 237, 300 to 237 is that angle there. Okay, so just to recap then, will I do this one? Why, I'll get rid of that. I can do this. Here's what I'll do as quickly as I can. T for tape measure there. Let's put a line along there. I'll take this through to the half span, that's a metre. And I'll take this through on the green to the end of the ridge. So that sets up the geometry. I'll set up my geometry shape out here. I'll do this one's just a little bit trickier because we need I'll take it up past that. I'll put a 70-degree roof on that. I'll take that off. Usually delete that out just so that I can put my steel squares in there. I don't know if I put any steel squares in here, have I? Not sure. No. Okay, that's all right. So that's the information that I'll need. I'll just triple click on that and make that a group. So to get this to happen then, to recap, hide that, put a square there which is the half span and back to the ridge. P for push pull. I think this one won't be quite as, I'll just make the same height as that, although I probably won't. Yeah, it might be further than that, but unhide, I'll double click on that, triple click, make that a group, and I can get rid of that in there, delete. So to find the angle then, here's what we do. Alpha line. Click. I'll double click on that and draw in it, not on it. So trying to pick up the angle there. Okay. Should be a meter. It is. All right. Click out, hide that, double click, alpha line. That's just the height of the ridge at 1 meter, and so that is the roof slope. That is the same slope as the roof. That's 70 degrees there. I'll hide this. That's the triangle there that we what we need, and it's this angle here, isn't it? This angle we need here. So I'll double click that, Q control, click, click. No need for an extension this time because what we wanted was the length of the hypotenuse in relation to a meter, and a meter rise. Let me get my thoughts here. Snooking myself. Snooking. Oh, went out to lunch there. So that's the length of the hypotenuse with that as the rise. This is the length of with that as the rise and that as the run. And now we want this in proportion. So that's the length of the hypotenuse now with that as the rise and that as the rise and that as the run. Anyway, that's exactly the length of the triangle we need here. So if I go unhide now, the angle that we want, there's the hip there. I'll draw in over the top of this now. Click, click, click. There's the triangle. I'll just put the layboard in there now. There's the layboard. That's exactly the bevel we need. There it is there. And you will probably do a better job at calculating that than I did using similar triangles. I don't know why I got confused. It's really consistent with what we were doing there and what we would do over here and that one. I might come back and do one more video just to tidy it up, but hope you're getting the drift. I think it's a tricky bevel. I don't think it's that easy to find, but when you see that, the length of the hypotenuse for 1 meter and for 1 meter run, and the length of the hip or the valley for 1 meter run, and the length of the hypotenuse for 1 meter rise.